Good day, everyone!
I am Teacher Debbie.
And I'm Teacher Jenny. We are your companion to explore the second quarter topics on mirrors and lenses. Welcome to Science 10! Here's our most essential learning competencies for today. Number 1. Predict the qualitative characteristics, orientation, type, and magnification of images formed by plane and curved mirrors and lenses. Number 2. Apply ray diagramming techniques in describing the characteristics and position of images formed by mirrors and lenses. Reflection and refraction are illustrated using mirrors and lenses. For today's exploration, you will learn about two properties of visible light, namely reflection and refraction, which are illustrated using mirrors and lenses. I am excited to explore these concepts with you today.
Time to play. To find out how ready you are to take up the topic for today, we will play What's the Mystery Word Challenge? For this activity, you will need the following: pen or pencil and a piece of paper.
Allow me to share the rules of this game. 1. We will give you 3 hints, which can be a word or a phrase. 2. There will be 5 levels in order to pass, in order to get the gold coins. 3. For every level, we will show you the mystery word with some missing letters. You will need to write the correct word in a piece of paper. For every correct answer, you will get a gold coin.
Again, we need 5 gold coins to win this challenge. And by the way, you only have 5 seconds to write the correct answer. Are you now ready?
Grade 10 learners, let's play What's the Mystery Word Challenge? Level 1.
Nice.
Great! The mystery word is light.
Light or visible light is electromagnetic radiation within the portion of the electromagnetic spectrum that can be perceived by the human eye. Visible light is usually defined as having wavelengths in the range of 400 to 700 nanometer.
Level 2. What is the mystery word?
Nice.
Very good! The mystery word is radiation.
Radiation is the term used to describe the transfer of energy in the form of electromagnetic wave.
Level 3. What is the mystery word?
Nice.
Excellent! The mystery word is radio wave.
Are the electromagnetic waves found at the left end of the electromagnetic spectrum, arranged from low frequencies to high frequencies. They are the type of electromagnetic waves with the longest wavelength, but they are of low frequencies, thereby carrying the lowest energy from among the electromagnetic waves.
Level 4. What is the mystery word?
Nice.
Marvelous! The answer is speed of light.
Speed of light is constant in a vacuum, which is 3.0 times 10 to the power of 8 meters per second. This is the fastest possible speed of transmission of signals through any medium.
Level 5. What is the mystery word?
Nice.
Amazing! The mystery word is electromagnetic wave.
Electromagnetic waves are disturbance that transfers energy through a field. They can travel through medium, But what makes them strange is that they can also transmit through empty space.
Let's have a quick review about light.
Light is a form of energy capable of stimulating the light's sensitive cells in the retina of the eye. It consists of waves and forms part of the electromagnetic spectrum.
Did you know light travels in straight lines? The path along which light energy travels are called rays.
Light rays are represented by straight lines with arrows to show their direction of motion. A beam of light is a bundle of light rays. Beams are represented by a group of rays which may be parallel, converging, or diverging.
Let us investigate the basic concept of reflection of light, which focuses on the law of reflection and the formation of images by flat or plane mirror and curved or spherical mirror.
We are able to see an object only when the light rays coming from it enters our eyes. Some objects, such as lamps and the sun, emit light and we are able to see them directly. They are known as luminous objects. Most objects, however, do not emit light in this way. It is called non-luminous objects. These are seen only because they reflect light from a source like the sun. Let's start with reflection and plane mirrors. Mirrors are smooth reflecting surfaces usually made of polished metal or glass that has been coated with some metallic substances. Mirrors can be curved or flat. Let us now first investigate on a mirror with a flat surface, which is called plane mirror. A plane mirror is a non-luminous object. Therefore, it is capable to reflect light.
Teacher Jen, I have a question. Why is it possible that you can see images in the mirror?
It is because of the property of light, which is called reflection.
Wow,
Here are some
nice.
important terms which you need to understand first. Incident ray. The ray of light approaching the mirror represented by an arrow approaching an optical element like mirrors. Deflected ray. The ray of light which leaves the mirror and is represented by an arrow pointing away from the mirror. Normal line. An imaginary line that can be drawn perpendicular to the surface of the mirror at the point of incidence where the ray strikes the mirror. The normal line divides the angle between the incident ray and the reflected ray into two equal angles. The angle between the incident ray and the normal is known as the angle of incidence, represented by small I. The angle between the reflected ray and the normal is known as the angle of reflection, represented by small r. The law of reflection states that when a ray of light reflects off a surface, the angle of the incidence is equal to the angle of reflection. Angle of incidence equals angle of reflection. I equals R.
How the eye sees an image in a plane mirror? The diagram shows that the light reflects off the mirror in such a manner that the angle of incidence is equal to the angle of reflection.
Are you lost after reflection? L-O-S-T. L for location of the image, O for the orientation of the image, S for the size of the image, and T for the type of the image. Let's summarize the characteristics of images formed by plane mirror. 1. L. Location of the image is behind the mirror. 2. O. Orientation of the image is upright or erect. 3. Size of the image is the same size as the object. 4. T. Type of the image is virtual. It cannot be projected on the screen. 5. The image from the plane mirror is laterally inverted. Example, left to right reversal.
You might have noticed that some emergency vehicles are often labeled in the front hood with reverse lettering, such as an ambulance. Why do you think so?
The answer? Most drivers will view the ambulance in their rear view mirrors. As such, they will be viewing an image of the lettering. Such images appear with left-right reversal and so will be viewed with a proper orientation. Example, ambulance.
Now let's explore reflections on curved mirrors. This type of mirrors are called spherical mirrors.
There are two types of spherical mirrors, concave and convex mirrors. Concave mirrors curves inward like a cave. It reflects light inward to one focal point. It is used to focus light, while convex mirrors curves outward. Its reflected surface bulges out towards the light source. Therefore, they are not used to focus light. You all must have seen the reflection of your face in a spoon. Spoon has two smooth surfaces, one curved inside and the other curved outside. However, it is not perfectly spherical. We can actually consider the reflecting surface, which is curved inwards, as a concave mirror. Take a stainless steel spoon, bring the outer side of the spoon near your face, and look into it. Do you see your image in it? Is this image different from what you see in a plane mirror? Is this image erect? Is the size of the image the same, smaller, or larger?
Before we explore about spherical mirrors, let us first be acquainted with some terms that will be used. A curved mirror has a principal axis, focal point, center of curvature, radius of curvature, vertex, and focal length. Principal axis, the line passing through center of curvature. Center of curvature is the center of the sphere from which the mirror is formed, denoted by the letter big C. Vertex, the point on the mirror's surface where the principal axis meets the mirror, denoted by the letter big V. Focal point, midway between the vertex and the center of curvature, denoted by the letter big F. Radius of curvature, the distance from the vertex to the center of curvature, denoted by the letter big R. Focal length, midway between the vertex and the center of a curvature is a point. The distance from the focal point to the vertex, denoted by the letter small f. When parallel rays of light hit a concave mirror, the rays are reflected inward, passing through the focus of the mirror. Hence, light rays actually converge or meet at a point. Concave mirror is also known as converging mirror. Thus, it formed a real image. For ray diagrams, we will have to recall the two rules of reflection for concave mirrors. Any incident ray traveling parallel to the principal axis on the way to the mirror will pass through the focal point upon reflection. Any incident ray passing through the focal point on the way to the mirror will travel parallel to the principal axis upon reflection. Here's an example of actual ray diagramming using a concave mirror, where the image of the person is located between the center of curvature, size is reduced, and type is real. Here's to summarize the object-image relationships using the LOST art of image description in a concave mirror. Case 1. The object is located beyond the center of curvature. Case 2. The object is located at the center of curvature. Case 3. The object is located between the center of curvature and the focal point. Case 4. The object is located at the focal point. Case 5. The object is located in front of the focal point. The object distance is less than the focal length of the concave mirror.
The convex mirror, also known as the diverging mirror, is a curved mirror in which the reflected surface bulges towards the light source.
Convex mirrors reflect light outwards, therefore, they are not used to focus light. Parallel rays diverge after reflection on a convex mirror. We learned that light is reflected by convex mirror in a manner that a virtual image is formed. We also learned that there are two simple rules of reflection for convex mirrors. 1. Any incident ray traveling parallel to the principal axis on the way to a convex mirror will reflect in such a manner that its extension will pass through the focal point. Any incident ray traveling towards a convex mirror such that its extension passes through the focal point will reflect and travel parallel to the principal axis. Any incident ray passing through the center of curvature on the way to the mirror will travel on its own path upon reflection.
Here's an example of an actual ray diagram using a convex mirror,
where the image of the person is located behind the mirror. Orientation is upright, size is reduced, and type is virtual.
Here's to summarize the object-image relationships using the LOST art of image description in a convex mirror. This diagram shows that an object placed this far away from the mirror would form a virtual, which is the light rays do not actually pass through this image, reduced, upright image. Security mirrors are convex, producing a smaller, upright image. Because the image is smaller, a larger area is imaged compared to what be observed for a flat mirror, and hence security is improved.
Refraction of light waves in lenses.
The tiny object on this man's finger is life-changing for him. It lets him see clearly without wearing glasses. You probably recognize the object as a contact lens. What is a lens? A lens is a transparent object with one or two curved surfaces. It is typically made of glass or clear plastic in the case of a contact lens. A lens refracts or bends light and forms an image. There are two basic types of lenses, concave and convex.
Rules for image formation by a convex lens.
Nice.
Rule 1. A ray of light traveling parallel to the principal axis, after refraction, passes through the focus on the other side of the lens. Rule 2. A ray of light passing through a focus on same side travels through lens and exits lens parallel to the principal axis. Rule 3. A ray of light passing through the center of lens will emerge without any deviation. Here's a sample ray diagram of a convex lens.
Here's to summarize the object-image relationships using the LOST art of image description in a convex lens.
Case 1. The object is located beyond the 2F point. Orientation inverted. Its size is reduced. The type of image is real. Case 2. The object is located at 2F points on the other side of the lens. Its orientation is inverted. Its size the same. The type of image is real. Case 3. The object is located between the 2F point and the focal point, beyond the 2F point on the other side of the lens. Orientation inverted. Size is enlarged and the type of image produced is real. Case 4. The object is located at the focal point. Therefore, there is no image formed. Case 5. The object is located somewhere on the same side of the lens as the object. Its orientation is upright. The size is enlarged and the type of image produced is virtual.
Rules for image formation by a concave lens. Rule 1. A ray of light traveling parallel to the principal axis appears to be coming from focus after refraction through the lens. Rule 2. A ray of light heading towards the focus becomes parallel to the principal axis after refraction through the lens. Rule 3. A ray of light passes straight through the optical center of lens and exists without bending. So there, you have learned the characteristics of images formed by plane and curved mirrors and lenses. Learners, let's see if you have grasped the essence of today's exploration. Let's have a 5-item pop quiz. Kindly prepare your paper and pen. For this pop quiz, I will read the questions and the choices once. You will be given 1 gold coin for every correct answer. Are you ready, learners? Let's play the Science Pop Quiz. Number 1. What type of lens is a magnifying glass? A. Convex. B. Concave. C. Parabolic. Or D. Plane. Go. Correct answer is letter A.
Question number 2. What is the bending of light rays due to a change in speed as the rays pass through a substance called A. Reflection, B. Refraction, C. Diffusion, or D. Diffraction? The correct answer is B. Refraction.
Number 3. Mirrors blank light rays to make an image. A. Reflect, B. Refract, C. Diffract, or D. Diffuse. Go! The correct answer is letter A.
Question number 4. What type of lens is this? A. Convex, B. Concave, C. Plane, D. Parabolic. The correct answer is B. Concave.
Number 5. Is a converging lens or a diverging lens? A. Converging, B. Diverging. Go! The correct answer is letter B. Great! How many gold coins have you collected? Well done, learners! Keep exploring and never stop learning.
See you next time in our next science exploration. That ends our adventure for today. Always remember,
Science is fun for everyone!
This has been Teacher Debbie.
And Teacher Jenny, see you next time to our next episode in Science 10!